Morning, grade 10. I have only here Margie. Okay. The rest are absent, even the metric, right? So let's move now to the examples. Okay. As what I had promised the last meeting, that I will give series of examples and series of applications for the gas laws, right? I'll be giving you some basics or basic problems with regards to gas laws. Okay. But before anything else, let me ask you, Margie, and the rest, how was your or how is your project going on? How is your project? The learning resource material, usually based on gas laws. Margie, how is your project? Are you doing now your project? Margie, still make me okay. Yeah, it's okay, right? Again, it should be based on gas laws. Okay. Um, for the benefit of those who are not here, just a reminder, your project, the learning resource material should be based on the fourth quarter, weeks 1 to 4 topic, okay? The gas laws. This is the module 1, right? And the module 2 is the applications. That is your learning resource material, right? So gas laws, under gas laws, you can use Boyle's or you can use any of the laws there incorporated with the topic. Okay, you may create, there are two categories or many categories of this project. First one is in digital output. Okay, digital output. This means this is actually in video format. Okay, since this is digital output. Okay, I can actually give you an example of the digital output that we have. Okay, this is actually the project of the previous year. Okay, their school year project. Okay, hold on. It could be in digital output or in physical output. Digital output means blogging and documentaries, video documentaries. The documentary should be narrated, or in physical output. Physical output means that this should be what? In physical, like for example, 3D of the science concept. Number one. Number two, diorama or 3 miniatures of the science concept or the science concept itself. Okay. I am reminding everybody and encouraging everyone to create again a physical output, since physical output has the biggest grade, okay, compared to the digital output. Okay. Hold on. I will let you see some of the outputs from last year. Okay. Students output. Let me show you this. Hold on. So let's have this one. Um, let me share this one. Can you see my shared screen? Dimitri and Margie? Okay. This is a blog, example of a blog, okay, in digital output.
Hello everybody, it's me, Kaylee Maxine Velosa, and for today we're going to be talking about a very interesting topic, gas laws. Let's start fresh. What are gas laws?
Well, gas laws are examples of scientific laws.
Hello everybody, it's me, Kaylee Maxine Velosa, and for today we're going to be talking about a very interesting topic, gas laws. Let's start fresh. What are gas laws?
Well, gas laws are examples of scientific laws. These are statements that describe, summarize, and predict a range of natural phenomena by means of repeated experiments and observations. Gas laws are laws that relate variables pressure, temperature, volume, and amount mathematically in order to make predictions about gas behavior, which is given in the kinetic molecular theory. Now, let me briefly introduce to you the gas laws and some of their real-life applications.
Formulated by Robert Boyle in the year 1662. This law describes the relationship between volume and pressure, claiming that the two variables are inversely proportional, which means that when the exerted pressure of a gas increases, the volume it occupies decreases, given that the temperature and amount is held constant. So when one goes up, the other goes down.
Deep-sea creatures are unlikely to survive on the surface of the waters because they are used to high pressure. Once they are brought up, decrease of pressure allows the gases in their bodies to expand, causing their air bladder and cells to rupture.
Chaucer's law, proposed by Jacques Charles in 1802. Given that the pressure is held constant, a gas's absolute temperature and the volume it occupies is in direct proportion, which means that what happens with one variable also happens to the other. An increase in temperature causes a corresponding increase of volume.
This law can be applied to baking. If you want your bread and cake spongy and soft, you would need yeast. Yeast is a leavening agent that converts sugars in the dough to carbon dioxide. Once the dough is put into the oven and baked in high temperature, the dough's gas expands, resulting to a spongy soft appearance for your pastry.
The relationship of the temperature and the pressure of a gas is described in a Montan's law, discovered by Guillaume Montans in the late 1600s. Just like the previous law, this law also describes a direct proportion relationship. When the temperature of a gas increases while the volume is held constant, it causes the pressure to increase too. He discovered this while building an air thermometer.
According to Montan's law, higher temperature results in higher pressure. The air pressure in tires increases as the temperature rises.
Driving excessively raises the temperature of the air in the tires. Doing that, especially in this hot weather, may blow up your tires due to overinflation. Better get your tires checked to avoid risky scenarios.
A pressure cooker is a cooking device that cooks food quickly. While the food is being heated inside, its fixed volume container traps the steam being generated, and as steam builds up, the pressure increases. This law is simply a combination of the three primary laws we just tackled. There are specific events that involves the variables temperature, volume, and pressure. Hence, requiring a combination of the three laws caused the discovery of the combined gas law.
Our lungs are the containers that hold air. As swimmers dive in the depths, they make sure that they know how to adjust to maintain proper pressure balance between their lungs and the water. Because the water pressure increases, and like stated in Boyle's law, volume will decrease. And applying Charles' law, diving in cold waters may squeeze your lungs until there's no air left for you to breathe. Same goes with diving on a warm weather. The volume of air in your lungs may expand quickly. Without exhaling, the air will build up inside.
Proposed by Amadeo Avogadro in the year 1811. This law states that under the same temperature and pressure, equal volumes contain an equal amount of molecules.
When blowing up balloons, the volume increases as you release gas particles into the balloon from your lungs. The balloon's volume will expand as you force more gas particles to it.
Just like the combined gas law, but the Avogadro's law is added. Scientists wanted to study the relation of gas molecules to its environment, But upon brainstorming for the perfect equation, there are always affecting factors such as intermolecular forces. So, they just came up with this gas equation to study gas behavior, despite some minor factors.
Airbags installed in cars is controlled by a sensor that detects a crash. When the car crashes, the controller alerts the system, triggering an inflator that burns chemicals such as sodium azide very rapidly to produce large volumes of gas to inflate the airbag. While this happens, the bag is also being compressed when deployed, decreasing its volume, resulting to its pressure to rise. However, the gases are being neutralized to prevent the bags to overinflate. And seconds later, after the deployment, the bags will start to deflate in order for you to get out of the car.
Lastly, we have the Dalton's law of partial pressures, discovered by John Dalton in 1801. This law states that the total pressure exerted by a mixture of gases is equal to the sum of the partial pressures of the individual gases.
This law is especially applied to atmospheric studies. The atmosphere is made up of gases, mainly nitrogen, oxygen, and carbon dioxide, and water vapor. Put together all the partial pressures of these individual gases, we get the total atmospheric pressure. Now you know the basic concepts and applications of these gas laws. I hope you learned a thing or two from this video, and I hope you understand the importance of these laws. Studying gas laws are important simply because these gas laws apply to our everyday lives. You may not realize the things you feel, see, hear, and smell can be explained by gas laws. These can even save your life. Till next time.
Alright, that is one of the example of a blog. Okay, but another example for the digital output is the documentary. Okay, for the documentary, I will let you see. Okay, documentary. By the way, these are outputs from last school year. Okay, again, take note. I'm reminding everybody that this is your output for this school year. Okay, this is your legacy. Okay, for the school. Okay, again, another example for a, a digital output in narration, okay, in documentary type. Okay, let me share this one.
Over the centuries, experts have been studying something that is unseen in our naked eyes, and that is gas. And since it is different from more visible things, studying this element is more difficult. For that reason, scientists came up with some things that are helpful for them to study gas itself, and those are the gas laws. Additionally, there were plenty of experts who have formulated their own gas laws, and each gas law has their own uses. However, how can we apply this in our daily lives? Let's find out in this video. This is Christian Inario, and you're watching Science Matters. Studying science is interesting, and this makes us formulate a lot of questions. For this topic, we tend to ask, what are the applications of these laws in our daily lives? To begin with, we will talk about the Boyle's law. This describes how the pressure of the gas tends to increase as the volume of the container decreases. According to the rule, if the volume is large, the pressure is low, because the particles cannot move quickly because they must move in a large container. On the other hand, if the volume is small, the pressure is high because the particles must move in a smaller container. You can observe a real-life application of Boyle's law when you fill your vehicle tire. As you push air into the tire, the increasing pressure reduces the volume of the air molecules by packing them together. The pressure in the pump has to always be higher than that which is inside the tire in order for more air to be pushed in. As the air temperature is more or less constant in that period of time, you can see a real-life example of Boyle's law occurring in front of you. We are down to our next law, and that is Charles' law. This law describes how gases tend to expand when heated. According to the law of Charles, volume and temperature are directly proportional to each other. A real-life application of Charles' law would be your vehicle tire. If you read your owner's manual carefully, it will mention that tire pressure should always be measured cold. That's because driving around heats up tires. Charles' law states that the gas should always occupy more space when heated. But the tire does not expand very much. This causes the tire pressure to be higher when warm. Consequently, measuring tire pressure when the tire is warm will give you the false impression that you have filled your tires with too much air. Now, we are going to discuss our third gas law, and that is the Avogadro's law. According to this law, the same amount of gases at the same temperature and pressure emit the same number of molecules, regardless of their chemical and physical properties. In other words, as temperature and pressure remain constant, the volume of the gas is directly proportional to the number of gas moles. A real-life evidence of this law is whenever you blow up a balloon. The volume of the balloon increases as you add moles of gas to the balloon by blowing it up. Basically speaking, the more moles, the larger the volume will become. Now, we are in a Monton's law. This law states that the pressure of an ideal gas varies directly with the absolute temperature when the volume of the sample is held constant. This means that lower temperature means lower pressure, and higher temperature means higher pressure. A real-life example of this is your vehicle tire. In hot summer days, the inflated tires of vehicles may burst. The bursting of tires is caused by a Monton's law. The inflated tires are under high pressure. When the temperature of the air rises, the pressure of the gas in the tubes also increases. After an unbearable point, the tires fracture. However, what makes gas law important? Actually, gas law make the studying of gases much easier. They can be used to determine the parameters of a mass of gas using theoretical means. For that reason, these said gas laws are truly of great importance, and I do believe that they are useful when studying the things that are not seen. Remember, there are still gas laws out there not being mentioned here. For that reason, I encourage you to do your research and be limitless. This has been Christian Inario, and always remember that science matters.
Right? So again, that is one of the example of a video documentary under digital output. Are you still with me? Are you still with me? MD, Dimitri, and Margie? Okay. So that's it. Okay. For the digital output, again, it could be in a blog form or in a documentary form, as long as it is narrated. And for the physical output, we have the 3D of the science concept, number one. Number two, we have also the miniature of the science concept. Okay. The third one is the diorama of the science concept, or again, the science concept itself. Okay. You can choose any of those. Okay. You choose one. Right? For the example, okay, how are we going to pass? Yeah. For digital output, it should be emailed to me, the original copy, so you can actually store it in your Google Drive and send the link to me, make it public so that I can download it and check on it. for the physical output, you need to drop it over to my box at school. Okay? Since I'll be going to school every Friday, check on your outputs. Okay. Again, the deadline for this is May 13. That is actually Friday. Okay. Any other question? Any other question? Okay. Let's move now to the examples, the one that I had actually promised to you that will be giving that I will be giving a series of examples and practical applications for gas laws. Okay, let's solve this problem. Okay, can you see my shared screen now? Okay, can you see my shared screen? Okay. The problem here, a balloon initially has the volume of 0.4 liters and a temperature of 20 degrees Celsius or centigrade. What will be the volume of the balloon after it is heated at 250 degrees centigrade? Okay, again, the problem states here that a balloon initially has a volume of 0.4 liters and a temperature of 20 degrees centigrade. What will be the volume of the balloon after it is heated at 250 degrees centigrade? So if we're going to look at it, again, there is a temperature and the volume. You check on the gas laws, what is the law that actually talks about temperature and volume. Okay, I will give you time to do your computation and let me see. Right? I'll give you 5 minutes to do that. You still have time. Yeah. Okay, and let me see your work after. Right? Are you still with me? Okay. Again, in solving scientific problems, you need to incorporate first, number one, what are the given? Okay. The second thing is you check on what is being asked in the problem. And then check if there are some formula to be used, incorporated to the problem, and solve. Do not forget to put also the units used there. Was it in degrees centigrade? Or was it in liters? It depends upon the question also. Okay. Again, I'll give you 5 minutes to do that. In my clock, it's 9:47. I still have time. Okay. Okay, time is up. Can I see your answers? Dimitri, MD, and Margie? Are you still with me? Okay, can I see your answers? Can I see your answers? It's 0.7. How about um the computation? Let me see the computation. All right. So please prepare your answers by next meeting. Okay. We still have time, but let's reserve that one by next meeting. Hopefully you can put it in a Microsoft Word or put it in a PowerPoint presentation and share it to the class. Right? Do you have any questions so far? Grade 10? Questions so far? Grade 10? Are you still with me? Okay. I think that will do for today, class. Thank you for your participation. MD, Dimitri, and Margie. Have a nice day, everyone. Take care. Bye-bye. Enjoy the rest of the day.